Yeah, I was doing the same thing. Mine was formulated to make a crap load of CSVs. Now just added in one, and so that did let me partially do it.
Okay. All right. If you look online, you will see the last lab there. Again, this is a new one, so I'm doing various things to try to make it maybe a little less painful first time out. It's always at least a little painful. Big thing I want to say, make sure I say it up front, is that because it hasn't really been battle tested like the other labs, if something looks wrong in the other labs, it's probably you, at least early on. In this one, I don't know. So maybe you need to poke me earlier rather than later. And in fact, I'm going to try to go through some of it with you this hour. Hopefully, maybe we'll scoop up the worst things. Okay, there's the stuff. So this one's set up really to be done on Hamming. It's a big neural net with a big data set. So hopefully that's not an issue. Has Hamming been treating you guys okay? Nick?
Hamming's been treating me fine. I tried to access your file and it says access restricted. No.
Well, there we go. Right out of the gate. Yeah, not sure. I set the permissions properly, I think. Access restricted, huh?
How long ago did you attempt to access right now?
No, I mean, if the files were there, they should. If the lab was published, it should be visible. Yeah, I'd like to know exactly what the error is. Okay, appreciate it. Okay, in the meantime, we'll talk about the general intent of this lab, and we'll launch it when it's actually possible to launch. How about that? Okay, so the main goal here is to give you additional experience training in neural net. Oh, the other main thing the reason I had Sakai up is because let me back up. Is also because it's liable to be rough. This is half the value this lab, so you should scale your ambitions correspondingly. So this is 50 points, and in fact, all the other there may be other assignments that we do over the next few days. I mean, I'm not sure. It depends a little bit about what stuff you guys give me in the assignment due tomorrow. But there might be some little assignments, but they'll just be a few points. So we're mostly through there. This is big compared to anything else I'm gonna ask you to do for these last few days here.
Okay. It says SFTP error number 3 mission.
Okay. I'll have to go and get some help from the Hamming people. Let me see. Yeah, okay. So I'm still going to talk through it now and demonstrate it. It sucks that you can't actually go along with me, but we're going to keep meeting. So we'll to be continued tomorrow, worst case. Okay. All right. So what's this about? We give you additional experience training in neural net. This network is quite a bit bigger, similar to the ones we use in the advanced course. In fact, it is one that I've used for material in the advanced course for, it depends on what we're doing that particular year. And it's also a convolutional neural net, which I don't mention here. You remember the vision example that I had, right? And the networks that have repeated weights, right? And then we'll go and look at each piece of the image to produce their new layer. Not that actually is very material to what you need to be thinking about for this lab. I mean, it's mostly convolutional neurons are like normal multi-layer perceptron neurons in that more of them lets you fit more, and it also lets you overfit more. And that's kind of the main thing you need to know as someone who's trying to train the network. And also, this is going to be very much oriented just toward the number that we get out at the end. We're not going to do anything with the network. We'll be doing a ton with this stuff in the summer. So it's not very fulfilling in terms of anything beyond the training of the network. But the point is the training of the network. All right. So The input dimension is quite a bit bigger than previous examples that we had, so therefore each exemplar is bigger, and also you need a good, I mean, I know from experience in this domain, you need quite a few examples, so what I've got out there is that the main training a set of examples is like 100,000 training examples. Yeah, so this is the reason why I can't really easily distribute the data to you, nor do I want to. You know, we could do that. I could find a way to do it, but it's not actually a good thing if we all go make our own copies of large files on hand. You know, we should try to avoid that. So hopefully when I go and cry to them this afternoon, they'll help me out and let me know what's wrong, and you'll be able to use the files sitting in my directory. That's my intent. Okay. Good. The other thing is, I wanted you all to have a chance to kick the tires on Optuna, which is a hyperparameter optimizer. Some of you have already done that, kind of more or less on your own, or maybe a slight suggestion from me, but this lab kind of has it built in, so it lowers the energy required to do that by a bit. Not to zero though, but by a bit. And then, yeah, code's provided. So you're going to work through the issues below. I'm also not asking you for a full lab report. Okay, I have some specific questions down at the bottom that I'd like you to answer. You're welcome to tell me more if you want, but I'm not asking you to go and write a report, just in the interest of not having a big thing that might be one more big thing at the end of a quarter. I don't know what the end quarters are like for you guys around here right now, but in the past, at least some quarters are very busy toward the end. So when I have the option, I try to avoid big assignments at the end of the quarter. So let's see. Okay, Aptuna. The provided code also assumes you're going to use early stopping. Now, one of the things that we saw in lab 2 is some people you actually went through some effort to implement early stopping, but didn't get great results from. Yeah, results were about the same or worse than using other kinds of approaches to avoiding overfitting. You know, like restricting the network size, like weight decay. And that could be the case for this too. So that the momentum here is like early stopping is kind of built into the code. If you don't want it, you've got to work to take it out, or maybe you want to compare them. I'd be very interested in seeing results where those are compared. Don't get me wrong, but I don't necessarily expect that. But just so you understand. I'm getting bitten by this a little bit right now because the only way that the system stops is by early stopping, meaning that it sees a minimum in the error on the stop data set. I can't do a quick demo of training network. It's long. It's not terrible. Like the default one, you can maybe train in 10, 15 minutes, depending on where you are on hand. Because the reason for that is that I scaled back on the size. 100,000 exemplars may sound like a lot, and it is a lot compared to the lab 2, but it's not a lot compared to what we'll use in the summer. We could easily use twice that or 3 times that. Okay. Good. And I am going to ask you to give me your best neural net. I'm not sure I'll be able to test them all. It depends on some infrastructure questions that I haven't fully resolved, but I hope to. So we'll see. Okay, so this was the going in plan. This probably will need to be adjusted, or at least I need to adjust something on my side. I made a directory inside of my world on Hamming, home CJ Darkin, called share. I set the permissions properly, so I thought, and I put a bunch of PT files here. You might recognize PT as being the PyTorch extension. So that's the way PyTorch wants their data files. So these 3 files are the minimum ones that are there. If you decide that you've had enough with early stopping and you don't want to do early stopping, or you want to just do it as one of multiple options, then there also is a combined file. This train-stop has both the train and the stop data together in one file. Because if you're not going to do early stopping, then that means you're just kind of disadvantaged compared to other people because they are using that stop data in a significant way. So you deserve to use it too if you want to use some other approach to controlling the complexity of the network. Okay. All right. And then let's just read down through this. So this is like in lieu of the lab report, right? So I want you to think about what hyperparameters you want Optuna to try to optimize. I'm really not giving you much to work on there, but we can go through that interactively. There isn't much in the written material. But it's not a secret, right? It's the parameters of the network or the parameters of the optimizer. Those are the main hyperparameters. Okay. Um, and the network, again, it looks a little different because it's a convolutional neural network, but it's all kind of there for you, and it's pretty obvious how to change the number of layers and the number of neurons per layer. Those would be the main ones. Okay. You can think of some additional ones that might be interesting, but those are the main ones. Oh, I think there a flattened layer. There's a flattened layer in there too. I didn't think of that. So there's two types of layers. The early ones are convolutional. You have some number of those, and then you'll have the thing flattened out into just a vector, right? In the interest of it's a regression problem where we're trying to predict a number. So we're going to flatten out into a vector and then have one linear unit at the output, just like in lab 2, actually. But here you have to do a little bit of extra work to make that happen. Okay. So you'll need to think about how many parameters or what are the important ones, or at least which ones do you want to start with, and design is what you're doing then is designing an initial experiment. You'll have to think about what's the lower bound that's interesting, what's the upper bound that's interesting, what increment size do you want Optuna to consider. So, for example, a learning rate, you might want it to go. Again, these are just kind of random numbers, and hopefully you have something better than just doing a complete a random interval. But if I felt sure it must be between 0.01 and 0.1, and I want to go at steps of 0.01 between 0.01 and 1, then I would have 0.01 for the low bound, 0.1 for the upper bound, 0.01 for the step. Okay. And now you might want to do this, and it's probably smarter to do this. Either maybe even starting outside of Optuna to do some initial trials just to kind of make sure you're in. Oh, I'm sorry. Trying to make sure that your bounded interval is not completely crazy. You might want to do either a small experiment with Optuna, and then you might want to do another one, and then maybe even another one to try to zero in and make sure you're fully optimized. Okay, so for each time you do that, I would like you to basically give me a table that says what variables you're doing and what ranges you're looking at. If you only do it one time, one table, but multiple times, then give me the multiple tables. Okay. And I want you to just think a little bit about, so just in the interest of not being completely insane, in terms of what your ask is, think about how many hyperparameter combinations are you generating? I mean, so basically, Tuna is working within the framework of a block design. Does that mean something to you all? A block designed experiment where you have your independent variables, you decide what their settings are, what interesting settings are, and then you consider all possible combinations, right? So you're working in this huge hypercube. So what you wouldn't like to do is just say, well, I mean, I don't know about the learning rate, so I'm going to go everywhere from 0 to 1,000 with steps of 0.00001, right? Let Optuna figure it out. Well, Optuna is not that smart. Okay, it's going to end up wasting time. It'll poke here and there. It'll do the best it can before it runs out of time, but it will run out of time. So if you think about how many combinations, figure out how long a typical run will actually takes you to run. Hopefully you're able to use the nodes with GPUs. Not all nodes on Hamming have GPUs, but if we can get you all to use the ones with GPUs, you'll get faster results. Yeah, communicate with me if there are issues about GPUs. I'm kind of assuming in the summer it's generally been the case. There's been enough GPUs, maybe just barely though, to actually let everyone go and do some amount of work with GPUs. I mean, we don't absolutely need it, but it might be as much as an order of magnitude slower without the GPUs. So we'll have much poorer results overall. We'll go there if we have to, but I like to avoid it. So if you figure out how long a run will take you, then figure out, okay, what are you actually asking for worst case? Now, I'm not actually sure. I don't know out of the box. So I would like to ask you to dig in a little bit to see, make sure that I've configured Altoona well enough that it actually will do pruning. It's certainly going to do sampling. Okay. It will try things in the design that you have specified. That's the sampling part. But the pruning part is that it should periodically look and figure out whether the run is still interesting. And I'm not 100% sure. Mostly when I've done this, I haven't really cared about pruning. And see what you can find out about that. It would be good if that can be turned on and help you to eliminate crazy runs. Right. Um, so so when we're using so this is more along the lines of the summer course. So now we're going into this is a lab where I'm asking you to try to use one of the scarce resources on this campus, which is not only just Hamming, but the specific subclusters in Hamming that have the GPUs, which are the most desirable ones. Okay. So I'm not sure how much runtime we can reasonably expect. To give you 2 weeks for the lab, and we'll see. I mean, but we definitely want to be, since it is a shared resource, we want to be good citizens about the whole thing. And there, communicate with me. If it's clearly jammed and like everything's going slowly, let me know, and maybe we can come up with some ground rules to kind of limit the amount of computation you need anybody is allowed to do, and that therefore we'll get through the
Can we
design.
collaborate with each other?
What's that?
Can we collaborate with each other?
Yeah, I don't know. I would probably prefer not from the point of view of the goal to actually give you more experience optimizing the network. There's not a whole lot to think about. There's a bunch of grunt work that's involved with it, but there's not a whole lot to think about. So I'm not sure there's enough mental load to share. Yeah. Now in the summer, it's true, we do work as teams, and that does make things a little better because then we have teams running experiments. So there are fewer experiments, not one
By
pursuit.
collaborate, I mean, if we start, it's like, I think the problem space is pretty large, so my initial schwack at type of parameter optimization takes a large chunk of area, and I'm like, all right, this is garbage. Can I just publish that result? Because that would at least remove the initial step from a lot of the people in the class. So looking where I've already turned the gauge, probably a promising area, and that should reduce the computational load that we all collect put on hand at the same time.
And how would you publish that
I
result?
would text everybody what I found.
Do you have a Teams channel or something already set up to do? Oh, but, I mean, because it's going to everybody, and maybe.
Yeah.
We could talk about that. If it's only going to half the class, and that kind of sucks for the other half. So, yeah, I guess if it goes to everybody, I guess I don't have a problem with that. But the problem is, I mean, how would you decide what's reasonable to share, right? I mean, so you could do a ton of work up front and really have narrowed in and have a design point that's already very good, and everyone else might just end up running that one. We actually had a case like that, and Chris ended up with the last lab, like his first guess at the parameters was like dead on. It was as good as anybody's lab 2 network, and so then he didn't do much other experimentation because everything else he did naturally looked bad. So that would completely defeat. So let's actually not do that, and let's maybe use other strategies to try to limit the if we find that it's a zoo on Hamming, which it could be because it's the end of a quarter, and this is a kind of a nice to have for us. So if it's terrible on Hamming, we'll back off as we need to just to to be good citizens. And by the way, you should not feel terrible if you get a nasty gram from one of the sysadmins saying, "Hey, what are you doing? You're burning all the CPU, or you're filling up the disk." They don't do that. So obviously you should try to avoid that. When you get that, you should definitely respond and take care of the issue. But what you shouldn't do is feel bad about it, because, the fact of the matter is that we're all, the standards for what's reasonable use of hamming have changed a lot over time and will continue to change as those nodes are upgraded. There will only be, more CPU around, more disk around. So we don't want students paralyzed with fear trying to use this tool, which you really need to use in order to get good results. So just, do your best, try to be reasonable. And if someone complains about it, okay. And maybe let me know as well. Just like, hey, I got yelled at for this weird thing, and if you let me know, I'll pass it on to the rest of the class so we all don't get yelled at for the same thing. But yeah, it's happened to most of it. I've avoided problems myself, but my thesis students very typically, we'll get a message from hamming at one point or another from the admin. Okay. All right. So, so this is basically just sanity checking your design. And I only expect you to do this one time. If you're going to do repeated experiments, you can just, the rest of the time, I just want the table, right? This is a piece that needs to be repeated every time you do another, tuna run. And then at the end, you're going to give me the best you have, right? So like, what was that actual value? How many trials did you actually attempt? Just because that's kind of an interesting number, right? In total, how many were pruned? I hope we can get pruning turned on and working properly. We'll see. And what were the hyperparameter values that were actually the best for you? So compare across the class. And then you'll zip up this document with your edits and your info in there, and then also your best neural network only. Please don't send me a million this time, because well, it'll just give me less grounds for error. As some of you know, if you send me more than one, sometimes I'll look at the wrong one. So give me the right one. Give me the one that's the best, and that's the one I'll look at. Okay, and the neural nets themselves shouldn't be any bigger. Shouldn't be much bigger than the ones in the past. I mean, it shouldn't be ridiculous. Should be submittable via Sakai easily. Okay, questions so far? All right. Now, right, so we're stuck on this point. As soon as we're done, I'm gonna go off and try to work on that. Let me just show you some other notes that I have here, and then we'll look at the code a little bit.
It looks like on hamming right now, there's only one idle node that has GPUs.
Yeah, well, I'm not too surprised about that, but it's not. The capacities of those servers is pretty crazy, in my experience. So that, an idle node literally has nothing running on it. Everything else would be called mixed, even if it just has one tiny job on it. So it might still have a huge amount of capacity. So I'm just not sure. But you'll know when you submit your stuff and you're like, okay, it's not running. It's just sitting, waiting for a node to become available. So you'll know you're delayed. And if those delays are significant, that's a time to poke meeting or replan as needed. Okay, so just a couple of desultory, comments here, but meant to help you. So it really helps to use GPUs. The clusters that I expect you guys, and since you're on hamming, Hunter, can you tell me? So if you do a sinfo, you should see all the clusters there, and there you should see Beards and Gen AI, I assume, at a minimum.
Yep.
Okay, do you see Barton there? Okay, that's what I figured. So Barton's still private. There might be another new, they're always adding new ones, and they don't tell me when they do. So if something new is there that you're aware has a GPU, and it's easy to test, right? You can write a Python program that you import Torch, that's PyTorch, and run this one function. If it says CUDA is available, there are GPUs that could help. So feel free to test, and if you test, do let me know. At least at the end of the lab. If you don't want to spoil your advantage of knowing that there's virgin nodes out there that could be helpful, that's fine. But after the fact, at least let me know. So let's see. And the main training code that I give you uses this to either print out that it's using the CPU or CUDA at the beginning. So if you think you may have thought I've done everything right, I'm on one of these clusters, surely it's GPU. Okay. You might get surprised sometimes, because if something went wrong during your install of code for your own Conda environment or whatever you're actually working in, I assume a Conda environment. You all use a Conda environment when you're on Hammy? Okay, good. But if you did something wrong with your install, despite all that, you might just say, I'm using the CPU. Okay, in that case, you want to maybe do some debugging. I'm not an expert in it, but I'd certainly try to help you. I'm sure the Hammy people will. We'll try to figure it out.
It looks like the other cluster that has GPUs is FSG. I don't know what that stands for.
Oh, that's completely new. FSG, huh? Okay. And how did you determine that?
You can do S control, which will show you the details for every node, and then you can filter it with grep to search for a GPU.
S control. What does it show what the GPU is?
It does. So the FSG. Actually, it doesn't show exactly what it is. L40S.
L40S. Yeah, okay. I'm not sure what that is, but there are other commands that will extract more info. Yeah, this is the kind of news I like to get. Yeah, and I don't know what this Bassett thing is either. Did you poke that one as well? Have you poked all of them?
Bassett did not return with the GPU.
Okay. Okay, so here's the FSG thing. It's just one node, but who knows? It might be good. Let's take note. Okay. So let's go over here. All right, so Optuna. So for those of you that haven't actually used it, I did say some things about the concepts and the algorithms in the notes. There were a couple of slides about that, but not anything really about how you actually use it. So CLI means command line interface. So these would be typical commands that you would type to Optuna, and there is actually a GUI way of doing these things too. But it's a little bit of a pain to get working on Hamming. If you really want to have the GUI, I would actually recommend maybe pulling your Optuna data, which normally looks like a log file. You just pull it down into your local machine and set up on your local machine to produce the GUI, and it produces it in a browser. And then you'll get some pretty pictures, but you can get all the key information just from the command line interface. Okay, so Optuna works in terms of studies, so it assumes you're using it maybe for a lot of different things at one time. So in our case, this is just kind of an overhead, right, where you're probably using it for just one thing right now, but you're going to have to give your study a name, MV3025 Lab 4, whatever. Call it something. In my case, I think it's called it Optuna_study. So this will tell you all the studies that you have, or remind you if you forgot what the name of your file is, but probably it's right there at the beginning of your log, maybe. Though actually, this is what they call the storage. So inside this one file, you actually could have multiple experiments with different names. So this shows the trials command shows what trials it's done. So what hyperparameter settings have been tried. It just dumps all of them. And this down here just kind of pulls off the best one. Okay. So you have to tell it. You got to give it the file with the info. You got to give it your study name. Okay. And when you give it both of those things, then it will tell you the best value. Okay. Now, another thing about Optuna is that it's pretty good about letting you interrupt an experiment and restart it. And this can happen it's very likely to happen on Hamming, depending on how you're configured. Because on Hamming, when you submit a job, you need to say what the maximum amount of time is that you're going to allow the job to run. If you say, well, let's give it a year. Okay, that's fine. And then you will be the lowest priority job of any that get run. Okay. So then you maybe want to be more aggressive. All right. So you say a day. Okay, but maybe your experiment doesn't get done in a day. And so it will just all get shut down after a certain point. But that's fine. You can really just go in and restart it like with zero work. In my experience, it will just start up. It will look in the log file. It will see what experiments have already been done, and it will just start doing additional ones. Now, inside the your code, you need to be set up, instrumented for using Optuna. So the whole idea is there are parameters in my code that normally would be like a number, like the learning rate would normally be like 0.1. Yeah, but I don't know if it should be 0.1, maybe 0.2, 0.3, 0.4, right? There are multiple options. So what you do is you use one of these calls here, depending on the type of data. Okay, the goal is just to attract your attention there. Categorical, meaning just like strings, for example. If you just want a string that's maybe used in your program somewhere, or whatever, be another example. Like maybe you want to use multiple optimizers, right? You want to, so my code's configured to use Atom out of the box, but you can see right there, it used to use stochastic gradient descent, SGD. Well, you could have either one then. I mean, as long as it works with the rest of your code, right? So if you call this out as the string SGD, then you need another if to go say, okay, and if the name is SGD, then actually, make the optimizer SGD, something. That's not hard. Okay. Yeah, and this name here is the variable name. So that's, you have to name everything, and then that makes it possible to actually understand what happens at the end and what the best parameter settings actually are. Now, once you get all done, or you're far enough along that you think, I have some neural nets here that I think are good. I want to know what they actually do on the test set. There is a test set, if you notice. Then the way you actually go and test it, there is no magic way to say, okay, Optuna, good job. Just go test the net on the best trial. Yeah, that would be something that's actually conceivable to do as far as I'm concerned. And maybe there's some way to do it that I don't know. I'm a pretty basic Optuna user, so I've only done a little bit with it, but I don't actually know how to do that. And from Googling around, it looks like what they want you to do is actually go and make a new neural network file, or replace the suggest with the actual best values. Okay, you can maybe comment out the suggests and put in the actual values, and then you ought to be able to run. There's a test neural net function which you could then use to run it and get a number for how good it actually is. Okay. Okay, any questions about this? That's a bit scattered and random, but it's good stuff that I would have wanted to have before I started working with this stuff. So I think it's at least add some amount of value. All right, so now what I want to do is just look and show you what this looks like, when it's working, which it appears will not be working for you right now, but maybe by the end of the day. We'll see. Okay, so I gave you the code. It was in where are we here? Okay, it was in a zip file called lab4.zip. Okay, so like this, right? And like I uploaded it and then unchecked it. Okay, and inside of lab4, so actually the top level directory is not where you want to work. You want to work down in the work subdirectory. Okay, so let's see, there's all kinds of stuff here that isn't really helpful, but just kind of got dragged along because it was easier to do that than to do some risky cutting. Okay, so down in the work directory, there's not a lot. Okay, these are like the key files to use. This one is a result file from running Optuna previously, even though it looks like I killed the neural nets, but I kept the result file. Okay, this .sh file is a file that's set up to be used with SBatch. Okay, so let's take a look at that first. All right. So this up here says I want to use the Beards partition. So if you do sinfo, you could see which clusters are less busy. And there may be ways to get like an OR of the partitions, but that's more Slurm knowledge than I have. Like if I want to use Beards or Gen AI or FGS, whatever the new guy is, why couldn't you just say an or somehow? I wouldn't be shocked if there's a way to do it, and I just don't know what it is. Okay. But I don't know what it is, so I have to actually go. I use SInfo, I figure out what cluster I want to work on, and then I go from there. This says that I want 1 GPU. This says that I want 20 gigabytes per process. And this here, time, there's actually a lot of nuance to this. There's multiple formats, but if you just do something like this, that 1 means run for a maximum of 1 day, 24 hours. And if it's still running at the end of that, will just terminate and let you know. Actually, it won't let you know, but it will just terminate. Okay, there's a way to, with some additional fields, to have it let you know as well. But just keeping it basic here. Okay, and what is this thing actually doing? Time is a Unix command just to track the total time that it runs. Python. -u is unbuffered output. So sometimes in these systems, if you don't do unbuffered output, the output kind of gets stored up for a long time before it actually becomes visible, which could be bad if you're doing something crazy and you would have known if it would have shown you that stuff instead of buffering it. So I can't stand that. So I do -u. Then this is the main training file right here, Aptuna train. And then I'm calling it the study, the Aptuna study, lab 4 study. Aptuna underscore nnet is a file with a PyTorch model file that's slightly set up for Aptuna. I'll show you that in a minute. So basically what I mean by slightly is that, no, it's actually fully set up for Aptuna, but there's only one parameter that varies, and it's the number of neurons per layer, I think, either 32 or 64. So the parameters are lower bound 32, upper bound 62, 64, step is 32. So that leaves 32 and 64. That's it. Okay, so a nice tiny experiment. And then this is the full path to those files. Again, if that changes, I'll let you know. Okay, and then when you're like that, now you can just go do sbatch lab 4 dot. Okay, well maybe you can't. Let's see, what's it doing? What happened? Oh my goodness. Okay. Not sure. I don't know if I hashed this just in my own. I hope I just hashed this in my own copy, but you might have to also fix this at the beginning. Could be I hashed it before I gave it to you guys. Okay, let's try it again. Batch lab 4. Okay, now it's running. Okay, right? And you guys should probably know this by now, but there's this SQ command, which is helpful. Minus me, meaning give me my processes, and just I do this routinely right after I start, just to make sure it didn't immediately crash. Right? If you've got a bug or something like that, often it will immediately crash, in which case then I can fix it and start again rather than coming back optimistically after an hour and checking in like, oh, it didn't run at all. Okay. All right, so it's running. Right, here's the Slurm file getting produced there. Let's just take a look. Okay, you can see, what can we see here? Using CUDA device. All right, good. Okay, that's what I'm hoping for. The study actually exists. I should have deleted that log file because the study's actually there. So this actually might stop really quickly because it'll say, well, everything's been tried. That's possible. I don't know what's actually in that log file. Okay. I have another log file somewhere else though, where the work is done. So I'm going to actually go over there just to kind of play around with Aptuna a little bit. Okay. And then I'll call it a day and go off and try to figure out what's going on with the file access, and you'll get email from me. All right. So let's see. Let's do this. Let me just see if it's still running. No, it's actually optimizing. Okay, let it. Okay. Now, actually, so if you don't want a run, like, the nuclear option here to get your stuff off Hamming is S cancel me, right? If you have multiple jobs running, it will go kill them all. And that's helpful. If you just got a message from someone saying, why are you doing X, Y, Z? And it's like, okay, I can just stop. We'll restart things, no problem. Okay, now somewhere here, I think I have an older version of this where an Optuna experiment has finished. Let's see. Maybe in server work. All right. All right, so this is what it might look like. So if you actually just run my literal code, it can create at most 2 neural networks, right? Just one with 32 hidden units per layer and one with 64 units per layer. Okay, so here they are, 0 and 1. Okay, it's using a name that I gave it as a prefix for these neural nets. You will notice, see this last thing? There are like secondary copies for each of these. And this is because of stuff like if you pull the plug by S canceling, or if you run out of time and the process stops right in the middle of writing a file or something like that. And these should be your best files, but if they're corrupted, you can go to the one that got written just before that, so the whole experiment isn't lost. You just have a slightly worse network maybe, but probably hardly so. Okay. All right, and then again, here's my log file. And if you look, these log files are actually readable, human readable, maybe not human friendly, but they're meant to be manipulated by the command line interface. Okay, but worst case, you can actually just look at this and see what the experiments were and what happened if you're willing to work a little bit. Okay, I'm not willing to work a little bit, so let's see. If I do, let me look at some examples here so I know what things are interesting. Okay, so right, let's do this. Let's get our studies here. All right, there it is. Tuna studies. And then what is it? Storage. And then lab 4 study log. Okay. All right. So again, this is probably not very helpful, but if you divide your work up into multiple studies, multiple experiments, and want to keep them all in your log file, then you will see multiple studies here. I only have the one. Okay. Next would be, let's see all the experiments that get run, right? So I got to use the study name. So tuna trials. So we got to tell it the storage again. All right, I gotta say, what is it? The trial? Study name with a hyphen. Okay, and our study name is lab4_study. This should just give me a dump of all the trials. Now, there aren't many here. It's a warning about some future API changes. Don't worry about that. Right, so here are the 2 things. Here are the hyperparameter settings. So if you have multiple hyperparameters, this will be a much bigger structure here. Here is what it tells you when it did the run. It gives you the actual value that got produced. Right, and if your file, in fact, is full of a lot of these things, then the best trial option should be good. Is it just best trial? Sure. Take a quick look. I think it's just best hyphen trial. Yeah, best hyphen trial will just give me the best one, which is hardly much of an improvement in my case because I only have 2, but so you see how it is. There you go. Just pulls out the best one. Okay. All right. I think that's all I want to do for today. Any parting shots before we go? All right. I'll work on file access and let you know. Okay, that's fine. Yeah.
So.